Hey guys, today we're going to be looking at basic vector addition. So let's go ahead and set up one of the problems so we can see what we're looking at. The type of problem we're doing is we're taking a vector of 4 meters, so this could be like a displacement of 4 meters, and then we're adding it to another displacement, let's say of 2 meters, and both of these are to the right. So notice that when I've drawn the vectors, the size of the arrow represents the length of this, so 4 meters in this case, 2 meters. And if I were going to do this perfectly, I would actually take a ruler and make sure that this arrow is half the size of that arrow. But we're just kind of doing this off the cuff, so I'm not going to go to that extreme. But the size of the arrow represents the size of the vector. Also, the direction of the arrow represents the direction of the vector. So both of these vectors point directly to the right. Now to add these, if I have vectors that are aligned in one dimension, that means that they form a straight line in between them. It's addition just like you know it. 4 plus 2 is 6. So our arrow would have a magnitude of 6, and it's still going in this direction. So again, think of a person walking 4 meters to the right, then they walk another 2 meters to the right. Their total displacement would be 6 meters to the right. Now, let's make this more complicated because, hey, this is physics class. That's what we do. Let's take that same 4-meter vector, and this time let's add to it a 2-meter vector in the other direction. So now, the physical situation, if you want to think of it that way, we've got a person has a displacement of 4 meters, and then they displace themselves 2 meters, but this time it's to the left. So when we do this, this basically is just turning into a subtraction problem. And so now our answer is 2 meters to the right. And here's the way this works. You can think of this, since these are again aligned in one dimension, you can form a straight line between them if you were to line them up. You can pick a direction to call positive. Now usually in our brains we think of positive as being in this direction to the right. So anything to the left is like saying that's a negative 2. And obviously 4 plus negative 2 would be 2. And notice our vector keeps the direction of whichever one is bigger when they're aligned in one dimension like this. And that works for up and down vectors as well. Let's look at this one. So let's say we have a vector that's 2 meters up plus 3 meters up. That would be a vector of, take a guess, you know what it is, 5 meters upward. So now that we've seen what to do if they're aligned in one dimension, we're going to take a step back from this and now try things where they're not aligned in one dimension. So here we go. Let's take one vector and we'll use our standard 4 meters to the right vector that we've been playing with. But now let's add that instead to our 3 meter upward vector. Now on this one, we obviously can't just do what we did. This is not going to be 7 meters in any direction, and the direction itself is not very clear from this. So here's what we have to do. We have to take our 2 vectors that we're adding. So our 4 meter vector, and I'm going to draw that in a dashed line. So there's our 4 meter vector. And we're going to take this other vector and we're going to put it tip to tail. So that's tip to tail with the other. So I'm going to take the tail of my 3 meter vector and put it against the tip of my 4 meter vector. And I'm going to draw the 3 meter vector over here, again with a dashed line. So now these are arranged tip to tail. To find the result of this addition, what I do is I connect the tail of my first one to the tip of my last one, just like that. And that vector right there is the answer. And we call this the resultant vector, which kind of makes sense because it's the result of adding the other two vectors. So anytime you have two vectors where they're not lined up, all you have to do is put them tip to tail, and the resultant vector will be the answer. Now in this one, we're lucky in that we have a 90-degree angle, so we can actually find the magnitude of the resultant vector. So it's 4 and 3. Since this is a right triangle, we can use the Pythagorean theorem, and we know that 4 squared plus 3 squared has to equal the magnitude of my resultant vector squared. So 4 squared is 16, 3 squared is 9, so 25 is the magnitude of my resultant vector squared. So you can see that the magnitude of this will actually be 5. So this would be a 5-meter displacement, and it would be up and to the right. You could also call that northeast if you wanted to. If these do not line up in a right triangle, the only option you have is to draw these to scale, to actually pick a scale and measure these out, draw them to scale here, and then measure the distance. That works, but it's pretty clunky, and later on in the course you'll get a mathematical way to do this that doesn't involve so much taking a ruler and actually measuring these out. But those are the basics. If they're aligned in one dimension, it's just addition and subtraction, just like we're used to. If they're not aligned in one dimension like these, you put them tip to tail and draw the resultant vector from the tail of the first one to the tip of the last one.